agenda number 3 is to have your foundations very solid so that you justify your right to be a student of computer science, right? So with these 3 agenda, I will talk of all past classes that I had been talking about. So I thought this class would be helpful for wrapping up everything that we discussed. And as usual, I would encourage interaction. You can ask me any question at any point of time. Okay, so shall we start or wait for some more time? What do you think? Other people are going to join?
We can start now. So we can
Yeah, we
start
can
now. So
start.
people, you've already
Yeah,
said people that to
yeah,
join. So
yeah,
anyway.
yeah. And I hope that most of the people who attend my classes seriously are already there, right?
Yes, sir. And I've shared the link as well, sir. They're joining.
Yeah, okay. And what about the board? You can magnify the board and see all the board work, right?
Yes, sir. Yes, sir.
That's good. That's good. Yeah. So, but nobody will log into the board right now because I will be working on the board. Huh? So please sign out if you have been logged in the board. So is the board helping you? Is it giving you a sort of a platform
Yes,
to
sir.
recollect things that we, yeah. So going through the board, you can recollect things, right? That we had been talking about. That's good. Okay, give me some time for my app to respond. Give me some time, okay? 2 minutes. Just check whether I'm audible.
Yes, sir. You're audible, sir.
Audible.
Am I audible?
Yes, sir. You're audible.
Okay. Yeah, okay. Okay, thank you. But my board is not working. Let me have some time. Are you sure you guys have signed out of the board? Just give me two more minutes. Huh? Just Yeah, I'm back. I assume that you can hear me, right? Just say once more.
Yes, sir. We are
Yes,
able
sir.
to.
Yes, yes.
Yes,
Yeah,
yes, sir.
yeah. Thank you. Yeah, my apps just was not working, so I had to restart my iPad. Okay, so let me go. Okay. So at some point of time, I was talking about some algebra that completely fits into the regular expression domain, right? And this was that part. I will elaborate it. I will elaborate to give you better insights. And before I do that, I have plans. I was thinking and planning that I would concentrate more on this picture, if you remember. This talks about the equivalence of NFAs, epsilon NFAs, NFAs, DFAs, and how regular expressions exactly denote those class of languages that are accepted by these machines, right? 1, 2, and 3. So I have this agenda also. But before that, I want to go to the class that with which I ended. And there, I had a very interesting question from some of you. I didn't remember the name. And that question was somewhere here. Just give me a moment. When we were deriving regular expressions from a given DFA, I hope nobody has any problems in justifying that particular way of finding regular expressions from DFAs, right? Yes or no?
No, sir.
Okay, that's very good. And here, what we did was, for this particular picture, we took a particular DFA from, and I took that DFA from the book only, so that it would be easy for you to correlate things. And here, I showed you how to calculate the values for the 0th k, right? I hope you remember, for the 0th k. You calculated the values for the 0th k, and then after calculating the values for the 0th k, we started calculating the for k equal to 1 values. And like that, we intended to have all the k equal to 1 values like this. These were the k equal to 0 values. And after having all the k equal to 1 values, you are going to use the recursive formula to find all the k equal to 2 values. And that's why you go on. And in the meantime, you are supposed to get certain expressions. Please unmute your microphones. You are going to get certain expressions that needs to be simplified. So expressions like this needs to be simplified, right? And I gave you certain ways of simplifying. For that, for example, if we start with epsilon plus 0 followed by 0 star, I showed you how to generate infinite sets, and then how to realize what this expression is all about, right? That is how we try to map things. Okay. So what was the explanation that I gave? I gave something like, we need to realize what is the set described by this expression. So we started with epsilon plus 0 followed by 0 star. and then we said that this plus is actually OR. So we kept epsilon, comma, then 0, then this 0, followed by, we just express 0 star as a set like this, infinite set, and then followed concatenation operations like this, and we generated the whole set, and then we interpreted the whole set, that this whole set, epsilon or 0 is nothing but 0 star. And in that sense, we derived that epsilon plus 0 followed by 0 star is nothing but 0 star. And then you replaced epsilon plus 0 followed by 0 star with 0 star in portions of your expressions to carry forward, right? And that way, I don't know why my pencil thickness is not working.
Sir, I think you can use the highlighter, sir. That would make it easier. Like the
But
other
the pencil thickness should be good, right? Why it's not working? I
you
don't
could
know.
use the other
Let me
pen, sir.
check.
So just open the pencil
Yeah.
option again.
Yeah, okay. This one?
Yes, sir. The one below the pencil. Yes, sir.
Okay. So that would be good. No, it's not working. See,
Okay, that's
it's
what
not working. Yeah. I think, I don't know why it is not working. Just now it was working. Okay, I have to just, okay. Did you understand what I was saying? So just recollect things that, so this was one way of, this was one mechanical way that seems, see, I am going to give a very important statement. Please be cool and listen to me. So the way that we derive that epsilon plus 0 followed by 0 star is actually 0 star, this whole process, it seems intuitive and it seems logical when we work with a pen and pencil, right? The way I am writing on board, that we are trying to think things, right? Like this. Okay, let me write it properly here. So epsilon plus 0 followed by 0 star. This was the case. So what we did, we tried to build a set that should be represented by this. So epsilon plus, that means OR. So epsilon should be there. And along with epsilon, other things should be there. What is that? That is 0 followed by, then we tried to expand what is 0 star. And that was epsilon followed by 0, followed by 0, 0, like that. Right? And then we carried on this exercise to find that, okay, it should be 0 concatenated with epsilon, followed by 0 concatenated with this 0, then this 0 for concatenated by 2 double zeros, right? And like that. And then we concluded that this is nothing but epsilon followed by a 0. So this is a 0, followed by double zeros, followed by triple zeros, like this. It goes on like this to an infinite set. And then we concluded that it should be 0 star. What I mean is this whole process of deriving and concluding, this process, it seems intuitive, and it gives us a good faith that, okay, this is how we conceptualize. But what I meant was, this is good on paper, right? As we are supposed to, we are habituated to solve problems on paper with a pen. Now, since we are studying computer science, so there is a subtle difference between pure mathematics and computer science, right? So we are going to use these concepts with one very important notion in our mind, that we need to automate things, and we need to automate things in a way that is called algorithmically, right? And for that, each particular action, it is better that each particular action should be defined in a very proper way, a very structured way, and in a very unambiguous way. So there should not be any scope of misinterpretation. See, what we are doing is we are trying to interpret. So see, we are first of all we are deducing a whole set from this 0 star, and then again we are coming back to an expression from a set, right? So we are doing two things that are self-contradictory. What we are doing, we are generating sets to find out what happens, and then from a set we are trying to deduce a regular expression, right? Now the question is, once you think of this as a computational job, we have to think of an algorithm that should actually convert this infinite set to an expression. Does such an algorithm exist? And if it exists, what should the cost of that algorithm? That is a very important computing question that you should have in your mind. Got my point? Because this is an infinite set. So immediate question should be, if we are to examine strings, how far shall we examine to conclude that the next element of that next string of that set should be exactly bearing the same character of this set? All the strings are bearing the same character. What is the character? It is 0 star. This character is 0 star. So zero number of zeros, that is epsilon, followed by 1 0, 2 zeros, 3 zeros. So we can, this set has strings that has any number of zeros. So characterization of this set, the algorithm that characterizes this set, we have to define that algorithm. Now the best way is to, to do such, what are these called? These are called, so the transition from epsilon from 0 followed by 0 star, that we decide that it is 0 star. This is nothing but an algebraic manipulation, right? And this algebraic manipulation is manifested in computing terms, in designing algorithms. If you have a set of rules, well-defined rules, unambiguous rules, a set of axioms. What type of axioms? Logical axioms that are already proved to be true. If you have a set of rules and your computing algorithm just goes and looks up to those set of rules. Why I'm talking about set of rules? I'm talking about set of rules because for each modular rule in that set of rules, you can efficiently design small algorithms.
So your voice is
Yeah, my voice is what? Yes, my voice is what? It's breaking. Can you listen to me?
Yes, sir, you're audible.
But somebody told my voice is breaking. Okay. Now the job of algebraic manipulation for deriving smaller expressions that are equivalent to bigger counterparts. For that you need a set of rules. For that you need to have a very well-defined algebra that gives you two advantages. One is equivalences. So in a sense, we say epsilon plus 0 followed by 0 star is equivalent to 0 star, right? We have equivalences. We can derive inequalities also. Now, why I'm talking about inequalities? Because when you are going to work with set of strings, theoretically, this is an infinite set, right? 0 star is an infinite set. But when you work with finite languages built out of infinite sets, then some sort of ordering, some sort of partial ordering between strings, between subsets proves important for two things. One is to have a positive answer for decision problems, and another is for better solution to finite domain problems. So it justifies the need of certain algebraic rules that would guide you through this process. Did you understand? That would guide you through this process of the manipulation, right? So let us go back to that example, where in this example, if this was the picture that we started with, and in that picture, what should be the language of this? What should be the language of this DFA? The language of the DFA should be the language expressed by the regular expression R1, 2, 3 union the language expressed by the regular expression R133, right? This is for just a recollection. What is R123? R123 gives you, R123 is a regular expression that expresses all strings that take you from 1 to 2, going through all possible states. That means it's a set of strings that take you from 1 to 2, going through 1, going through 2, and going through 3 also, because of this 3, right? Union, all possible strings that take you from 1 to 3, going through all possible states. Now, what does that mean? It means all strings that are accepted, because you have two accepting states, Q1 and Q2. So the language of this finite automata is this. But for deriving R1 to 3, you need everything below the third level. That means all Rij2s, and all Rij2s should be including all strings that are represented by Rij1, and that should in turn include all strings represented by Rij0. So this 0, this 1, this 2, and these 3 are nothing but indices of levels of strings, right? So if we say that, okay, we have all Rij0s, that means with all Rij0s you can create all Rij1s. With all Rij1s you create all Rij2s, and with all Rij2s you create Rij3s, right? That means all Rij1s should include Rij0s, all Rij2s should include Rij1s, all Rij3s should include Rij2s. So if you have a definition for this, if you have an expression for this, if you are intending to express Rij3, that means you include all strings below the third level. So that's why this process is recursive, and I already explained you what is the importance of recursion, because it stops if it doesn't find relevant things under some values of k. So that justifies the construction of this beautiful theorem. Got my point? But I want to take you to some point where there is a need of algebraic rules for all these reasons that I've given you, right? And I was talking about clean algebra, and without clean algebra, this portion is never complete. So I told you, I gave a statement in some previous classes that there is a free algebra called clean algebra. Why free algebra? There are instances where this clean algebra seamlessly is able to represent many things, and out of those things, one very important is the expression for regular expressions, right? Now, what is this clean algebra? I will show you. So based on your concepts of regular expressions, now I would ask you a question. If R is a regular expression, if P is a regular expression, and if S is a regular expression, and if I express R, P's and S in some way like this, R plus bracket P plus S. Now my question is it equivalent to R plus P bracket plus S? Are they equivalent? That is my question. Think of a regular expression. Now don't forget that a single symbol is a regular expression, phi is a regular expression, epsilon is a regular expression, and all expressions built on phi's, epsilons, and single symbols added to the fact that R plus S is a regular expression, RS is a regular expression, and R star is a regular expression, right? Do you remember? So a single symbol is a regular expression, epsilon is a regular expression, phi is a regular expression. These are the basic base cases. Added to them were these. And with all this, we generate more and more regular expressions. I showed you with induction and theorem proving. Now my question is, if R, P, and S are three regular expressions, and if I combine them in an expression like this, is this one is one equivalent to 2? Yes or no? Yes. Why? First of all, we are dealing with operators, binary operators. Plus is ORing. So one means R or P or S, right? So it doesn't matter whether you put a bracket or not. So since it doesn't matter, since this is an OR, it doesn't matter whether you put a bracket on S, it is equivalent if it is bracketless also, right? So it is equivalent to saying R or P or S. Do you agree with me? So let us take two irregular expressions. A symbol A plus B star plus C followed by A star. Now, what I mean is this, if I write in a bracketed notation like this, should be equivalent to A plus B star plus C A star, C A star. It's all the same. That is what I mean. Because both the operations are OR, right? Got my point? Now I have a question. Okay. Similarly, if I say that you have regular expressions R, P, and S, and if I write P followed by Q plus R, is it equivalent to? I am asking you, is it equivalent to P dot Q plus P dot R? Now answer me. Is this equality possible? Am I audible?
Yes, sir.
So is this equality possible also? I have changed the operator. So you have a concatenation operator outside the bracket and you have a plus operator inside the bracket. So my question is the left hand side equivalent to right hand side? Is it possible to have this?
No, sir.
Why? P, Q, and R are regular expressions. Why it is not possible? Since P, Q, and R are regular expressions, why it is not possible? So if this is not possible, now let me ask you, if this is not possible, how did you agree that if this is not possible, how did you agree to this? How did you agree to this construction? It was 0 followed by an infinite set. And then you did something like 0 dot epsilon, 0 dot 0, 0 dot 0, 0, 0 dot 0, 0, 0. And you got a set like this. Right? Is it?
Yes.
You did this operation,
Yes, sir.
right?
Yes, sir. Yes, sir.
Yeah, what is so don't complicate things. Let us take examples. So let us talk about, let P be a single symbol A, let Q be a single symbol epsilon, and let R be a single symbol B. So the left hand side is A epsilon plus B. What is this? A concatenated with epsilon plus B. What is epsilon plus B? Either you take epsilon or you take B. So you get A dot epsilon or you get A dot B. That is what you get, right? I am writing OR with this symbol. So this expression means either epsilon or B. So when I try to realize expression with a value, either I get an epsilon or a B. If I get an epsilon, it should be A dot epsilon. If I get a B, it should be A dot B. How do I write this? I write in an expression A dot epsilon plus A dot B. So A dot epsilon or A dot B is written like this because this is OR. Agreed or not?
Yes, sir.
Agreed or not? So if this is the case, what was epsilon? Epsilon was nothing, but what was A? A was P. What was epsilon? It was Q. What is A? A was P. And what is B? B was R. So P dot Q plus P dot R. That is what I have written. Does it make sense? Yes or no?
Yes, sir.
Yes
Could you
or no?
explain again, sir? Sir, could you explain again, sir? I was a little confused.
Explain again. Little confused. So, okay, what we are talking about? We are talking about simplifying parts of expressions to and defining equivalences that we may use in simplifying bigger regular expressions to more expressive, smaller regular expressions, right? Where did the question come from? The question came from that particular theorem where we were trying to find out Rijk values based on Rijk minus 1 values, based on Rijk minus 2 values, based on Rijk minus 3 values, based on Rij 0 values, right? So when we were defining expressions for higher values of k, there are situations where you have clumsy expressions, sub-expressions, and those clumsy sub-expressions should be equivalently stated in terms of smaller but more powerful expressions, equivalent expressions, like epsilon plus 0 followed by 0 star. We replace this with 0 star, right? Got my point? Now, I am arguing with a concept that the way we derived epsilon plus 0 followed by 0 star, and we said that it is equivalent to 0 star only, that way may not be algorithmically suitable, may not be a very computational way to do. That way of doing is better if we do things on pen and paper. Now, what I'm saying is that if we have algebraic rules that can be applied to such bigger expressions, and applying algebraic rules, if we can mechanically convert them to smaller expressions, that is better, computationally feasible. Because for each such rules, you can write small codes, or you can define small algorithms that you can use, that you are confident to converge in good time. Got my point? And that's why I'm talking about algebraic equivalences, axioms, rules. And I'm talking about one such rule and asking you whether one such rule is possible or not. I'm not forcing it on you. I'm just asking you. So I have said that let this be the left-hand side. Let this be the left-hand side, right? Let this be the left-hand side. I'm asking you, is this expression equivalent to this right-hand side? And I immediately got an answer as no. Then I'm trying to think that, okay, is the answer really no? And we found that the answer is not no, it is yes. This is equivalent. And what is that? What is that? It is concatenation distributes over union. This rule is nothing but a distributed rule, right? It's a distributory axiom. Simple things. Just try to recollect from your discrete mathematics classes. So this is nothing but concatenation distributes freely over union. Now I can write another counterpart to this also. I can write P plus Q dot R is P dot R plus Q dot R. Here, right? So here the union operator distributes, and this is another distributivity axiom. Now I said that why it is equivalent. So I said I argued for a yes answer, and I tried to show you why it is equivalent. So P Q plus R. What is this? P Q plus R. What is Q plus R? When you realize this, it means that you either have a Q or you have an R. Right? So P concatenated with either a Q or P concatenated with an R. So P gets concatenated with either a Q or it gets concatenated with an R. Not both together. It's an OR. That's the justification of this expression, right? So I say that, okay, I write this nothing but algebraically. So it is P dot Q, or I give a plus P dot R. Very simple derivation, right? So P followed by Q plus R in bracket concatenated. Q plus R in bracket is nothing but P dot Q or P dot R. Now, does it justify? Yes or no? So all terms that I am trying to explain you in a human way is mechanized with this expression and with the same logic. P plus Q R is nothing but PR plus QR. Now, what are these axioms of some algebra? I have not named that algebra yet. What are those axioms? These axioms are distributivity axioms, right? Also, we have seen that it uniformly distributes over itself. What is it? It is the plus operator. So P plus Q plus R. Okay, we can also show that A plus B. What is A plus B? The two regular expressions. Okay, let me simplify things. So I can also say that P plus Q be two regular expressions is equivalent to Q plus P. Why? Because it's an OR. It's an OR. P or Q is same as Q or P. It's an OR. Right? Now I ask you, is it the case that P dot Q is also equal to Q dot P? No, it is not possible in our case, because P is a regular expression capable of talking about certain strings. Q is a regular expression capable of talking about certain strings. And if it is so, if we say that this is not possible, because P dot Q means Q follows only when P is exhausted, right? Q starts when P is exhausted. And here it means that Q comes first and then P. No, the meaning has changed. P dot Q means Q concatenated after P. So it can never be same as Q concatenated by P. So such axiom should not exist in our regular expression definition. Got my point? Yes or no? But what was P plus Q equal to Q plus P? This is possible because this is simple ORing. P or Q is same as Q or P. Agreed? So this is what is this called, by the way? This is commutativity, right? So it is our whatever be the algebra, our algebra for specifying regular expressions can be commutative over plus, but it cannot be commutative over dot. So I am noting down just observations, right? So what should be, if P is a regular expression and phi is a regular expression, what should be P plus phi? It is P. Agreed? Yes or no?
Yes, sir.
Yes. Now, if P is a regular expression, I write P or P. What is this? Is it possible? P or P is P. Come on, it is possible. Now just go back to your discrete maths class. What is this called? Idempotence. Remember?
Idempotence, sir.
Yeah, idempotence. This is idempotence. This is true. Now, what is P followed by QR? If I write P followed by Q followed by R, is it possible? Yes or no? Yes, it is possible. Why it is possible? Because again, this is a
the order is
concatenation.
same, sir.
Yeah, the order is same. Exactly. Very good. So it is now here the operator is same, concatenation, right? And since the operation is same, you can very well ignore these brackets. No problem. Since you can ignore these brackets freely, see why I'm talking about this term freely again and again. I see, once we are trying to define an algebra, the set of rules, it should be uniform, it should be universal, and it should be general, as general as possible. That's why I'm talking about these rules. So this is possible, right? No problem. Now, with our concept of epsilon. So if P is a regular expression, epsilon followed by P is P. And P followed by epsilon is also P. Done? Do you agree? Yes or no?
Yes,
Somebody
sir.
please. Yeah, it's okay. It's no problem, right? So what is this epsilon called? Identity element. Okay, so if we put all the rules in a structure, then that structure has an identity element. Now, are you happy with the proper statement? Okay, let us talk about phi. So what is phi concatenated with a regular expression P? It is phi. Agreed? P
Yes,
concatenated with a regular with P concatenated with a phi is phi. What is this called? Phi is called an annihilator. See, I am talking about very simple things that you know. Got my point? So let me write it down in a clearer way. Let me do some clear board work, right? So what I say is, regular expression is nothing but regular expressions can be expressed algebraically. It's a way of algebraically expressing strings and sets, right? Often those sets are often what you call it, infinite sets, right? So regular expressions, the whole dome of regular expressions can be represented by an algebra. Say its name is regular expression algebra. So how to write algebras? Do you remember groups and rings and all those things? Don't worry if you don't remember. There is nothing to worry if you don't remember. I will show you how things are such simple that you do not panic to remember. So let RE be a structure. Let its name be RE, and you have operators like plus. You have operators like the concatenation operator, and you have the clean closure operator, and you have a phi, and you have an epsilon. So this is the regular expression algebra structure. And in this structure, you have certain axioms. Let me write it properly. What are those axioms? P plus Q plus R is P plus Q plus R. Axiom number 2. P plus Q is same as Q plus P. Right? Just now we talked about this. Axiom number 3. P plus phi is P. Axiom number 4. P plus P is P. Idempotence, right? Then 5. Now let us concentrate on the concatenation operator. So we have written 4 rules for the plus operator, right? So let us concentrate on the concatenation operator. So P concatenated by QR in bracket is same as P concatenated by Q bracket concatenated by R. Because somebody of you said that the order is same and the operators are same both outside and inside the brackets. So no problem. So let us come to 6. Epsilon followed by P is nothing but P. Let us come to 7. See, I am deriving things based on understanding. Neither I am memorizing things, nor I need you to memorize things. These are simple rules that we are trying to deduce based on your concept of regular expressions that you have built with those 3 basic building blocks and 3 rules, right? So it is P followed by epsilon is P. Then we have, let us combine. So these 3 are the dot rules. These 4 are the plus rules, right? I'm doing a good board work now. So let us combine the plus rules and the dot rules and let us write something like this. And I have shown you that they are same. Rule number 9. Let us put the bracket this side and it comes to be as, right? Rule number 10. Rule number 11. Got it? Yes or no? Yes or no? Yes or no? Okay, done. Now let me take into account everything so that I can see everything. So this is nothing but the regular expression algebra. Do you agree with me? This is the regular expression algebra. And how to find what character it has? See, it's so simple and interesting. So rule numbers 1 to 4, you can define this as regular expression on plus and phi. You can define that this is nothing but a regular expression structure on dot and epsilon. Yes or no? These 4 rules show that regular expression is a structure with plus and phi. Only one operator. What is this called? It's called a monoid. Right? It's called a monoid. You have only one operator phi, a plus. Right? And what is this? These 3 rules show that okay, regular expression also is a structure, also is a monoid over dot. This is also a monoid. But this monoid is commutative over plus. This monoid is commutative over plus. Yes? Yes or no? This monoid is commutative over plus. It commutes. But this monoid is not commutative over a dot. P dot Q is not commutative over dot, right? We have seen that P dot Q is not equivalent to Q dot P. So you can write that this structure, the structure defined by these four rules merely is an idempotent commutative monoid. This is the idempotent rule. So this is an idempotent commutative monoid. What is this? These three rules say that, okay, regular expression is an idempotent commutative monoid over plus. Regular expression is also a simple monoid over dot. It doesn't commute over dot, right? And it doesn't have the idempotence also. So it's a simple monoid over dot. And all these 11 rules taken at the same time is nothing but an idempotent semiring. Now don't ask me what a semiring is. I hope all of you know what a semiring is. So what is this? Now this algebraic structure of regular expression is nothing but a semiring. Now you find an application of rings that you studied in discrete maths. Agreed and happy? Yes? So regular expressions is nothing but a structure over plus and dot and star and phi's and epsilons. Written as a tuple like this, it's a semiring with such axioms that are always true and universal and generalized. And what I mean by universal and generalization is that any of these axioms can be replaced in any of the other axioms to deduce other equalities or inequalities. Right? Yes or no? Am I audible?
Audible. So could you zoom in, sir? Because the board is not visible at all now, sir. Because of the light.
Now?
Yes, sir.
Yeah,
Yes, sir. Yes, sir.
Now it is visible?
Yes, sir. Yes,
Yeah.
sir.
So what I was saying, regular expression is a structure whose name is RE with operators plus, dot, star, and phi and epsilon is nothing but a semiring. That is my conclusion. You have studied rings, fields, groups, right? So you should be knowing what are semirings. So in semirings, what happens? There is no requirement for an additive inverse and a multiplicative inverse, right? So, okay, forget about all those names. There is nothing kept in the name. What I mean is that we have built this structure very conceptually based on our observations on regular expressions. And we have defined certain rules. This is rule number 1, this is rule number 2, this is rule number 3, 4. And we see that these 4 rules say that, okay, regular expression is a idempotent commutative monoid, because these 4 rules deal with only the plus operator, right? The monoid means a structure with only one operator. And we show that 5, 6, 7 is not commutative over dot. So it's a simple monoid. Regular expression is also a simple monoid structure over dot. So regular expression is a idempotent commutative structure over plus. Regular expression is a simple monoid structure over dot. And taken into consideration all these 11 rules that we have written right now, this is nothing but a idempotent semiring. So it justifies the fact that, okay, regular expression algebra is regular expressions are derived, follows from or something called a regular algebra. And that algebra, why we call it an algebra and a free algebra, a most general form, because any of these rules can be replaced with any other to derive other rules, right? Other expressions. For example, let us find out a very simple derivation. So using all these things, we can write like Epsilon followed by P star is P star. Right? So 12, rule number 12 is derived from 1 to 11. Now just replace P with 0. Epsilon followed by 0 star is 0 star. This is exactly what we started the class with, where we tried to expand the left hand side into sets and then tried to find out a meaning of that set, and it stood out to be 0 star, right? Yes or no? Now my argument is, without going to generate sets and again coming back from sets to expressions, what if we have established algebraic rule like this, which can again be used in any of the above rules. You can just replace an act, right? Got my point? So we can derive another rule that is simple. Epsilon followed by P star P is P star. It follows from symmetry, no problem whatsoever, right? Got my point? Yes or no? You can derive other rules based on the basic rules as P followed by QP star is nothing but PQ star followed by P. Now, I may give questions to prove such equalities. And then you have to keep in mind this algebra and its rules and show me a derivation that, okay, the left hand side is really equivalent to the right hand side. Got my point? There can be other rules. This rule is a very popular rule. This is called a sliding rule. The bracket just slides. But taking this star operation into account, this is no simple sliding. It's sliding over star. Okay, there can be other derivation rules like very interesting, P star Q P star whole star is nothing but P plus Q whole star, right? This is another rule that can be derived from the algebra itself. Got my point? So so that ends the part of this discussion, and I want to say that all these things are exactly the same if we say that, okay, there is a free algebra available, and that algebra is called a clean algebra. And clean algebra, clean is the name of a scientist after whose name you define the clean star operation, right? So there is an algebra with the same axioms and rules. It's called a clean algebra. That is also defined over plus, dot, and star, and 0 and 1. That is called a clean algebra. It's a free algebra, where in this free algebra we have replaced this Ka with regular expression because it's the name of our algebra, regular expression. We have interpreted the plus of the clean algebra with the or in our regular expression case. We have interpreted this dot operation of the free algebra, generic algebra, with a concatenation operation in our regular expression domain. We have interpreted this star as repetitions in our regular expression domain. We have interpreted this 0 with a phi in our regular expression domain, and we have interpreted this 1 with an epsilon in the regular expression domain. Now this clean algebra has other uses in other domains also, but I would try to control myself not to talk about those beautiful things because it will complicate issues. So what we conclude is regular expressions directly follow clean algebra rules, and based on the discussion, and it's a structure, it's a semi-ring structure. It's algebraic structure, semi-ring over plus, dot, star, and the basic and you have concatenation identity, and you have an annihilator file. Does it make sense? Yes? Yes or no? Yes or no?
Yes, sir. Yes, sir.
Okay. So only one yes. Other people, no answer from other people. Okay. So shall I end? Do you want that I end the class?
Sir, actually, a lot of our net connections have gone down already, sir.
Yeah. I got it. Okay. So do I need to share the board, or you
Yes, sir.
can
It would really help. It would really help if you could share the board, sir.
No. Somebody told that once I share the board is always updated. Is it true or false?
Yes, sir, it is true, sir.
Yes, sir.
It gets updated, right?
Yes, sir.
Yes, sir.
Okay.
Sir,
So there is no need to
if
share
you're
it
using the
again.
same board, sir, if you're using the same board, then it gets updated. Like if you
Yeah,
keep
it's the same board. Some people has renamed the board as Shubhri sir's second board, right? I have used the second board today.
okay.
Yes, sir.
Okay. Okay.
Okay, sir.
Okay. Bye. Have a nice
Thank
day.
you, sir.
Thank you, sir.
Yeah.
Thank you,
Okay.
sir.
Thank you.